So we would like to compute the limit of this quotient that has square roots. And once more, we would like to emphasize what we do in order to get rid of the square root. So first of all, one should try to plug in the number that is being approached, which in this case it's 2. Don't assume anything, just always begin the computation of such a limit by plugging in and seeing what you get. So what you're going to get here is 0 over 0, because on the top we will get the square root of 9 minus 3, and square root of 9 is 3. And on the bottom we're going to get square root of 16 minus 4, and square root of 16 is 4. So what we would like to have here is, for example, on the top, we would love to have the quantity x plus 7 square minus 3 square. Why? Because for the first one, the square root disappears. This becomes x plus 7 minus 9, which, by the way, is x minus 2. And we would be able to also do that on the bottom. However, we cannot just put those squares there out of a blue sky. So the idea is that in general, we can multiply by the sum and also divide by the sum so as to balance out everything. So in other words, this is equal to this. And yes, we get what we want on the top, but we also gain this extra denominator. However, for all intents and purposes, this is not too bad because we can just plug in 2, and this is not, we're not going to get a zero quantity. At this point also, let us emphasize that the identity at work here is a squared minus b squared is equal to a minus b times a plus b. In our case, we have the a minus b part, and we want to create the a plus b part by multiplying and dividing. In this example, we will have to do this twice, once for the numerator, once for the denominator. So let's get to it. So we will have the limit as x tends to 2 of square root of x plus 7 minus 3 over square root of x plus 14 minus 4 is equal, and what we do is we multiply. Let's do it this way so as to show what is really going on. So let's pretend that we could put the things that we want there with a magic hand. In mathematics, there are no magic hands, so that's what I would like to have. Okay, because I could multiply those things out and get essentially this on the top, which simplifies and becomes that. That would be great. But I cannot just leave it like that and pretend that that magic hand exists. So what I do is the extra thing we multiplied by on the top, I also put it on the bottom. So this way everything balances out and it's as if no change was made. And what I multiplied by on the bottom, I also put it on the top. So everything now is balanced out. And what I can do is multiply these two things together here and these two things together here. And what do I get? I get square root of x plus 7 squared minus 3 squared times square root of x plus 14 plus 4 divided by square root of x plus 14 squared minus 4 squared times square root of x plus 7 plus 3, which is equal to the limit as x tends to 2 of x plus 7 minus 9 on the top times square root of x plus 14 plus 4 divided by x plus 14 minus 16 times square root of x plus 7 plus 3. And here, let's make sure that we all understand what just happened. This x plus 7 was obtained by square root of x plus 7 all squared. So in some sense, the square root and the square cancel each other. And 3 squared is 9. Same thing for the bottom. So now we actually do the little computation. So how much is 7 minus 9? That's negative 2. So we get an x minus 2 on the top. And by getting this x minus 2, what happens is that we actually demonstrate, we bring up the term which is responsible for the numerator being 0. Same thing for the denominator. And not only do we bring them up, but these terms are getting cancelled. So this gets cancelled with that. And now what we're left with are quantities that do not have any risk of generating the dreaded 0 over 0. So we have square root of x plus 14 plus a 4, that's the important part, and square root of x plus 7 plus 3. So this is equal to, now we can plug in, which means we drop the limit notation. So this becomes square root of 2 plus 14 plus 4 over square root of 2 plus 7 plus 3, which is equal to, let's work this out, square root of 16 plus 4 over square root of 9 plus 3, which is 4 plus 4 over 3 plus 3, which is 8 over 6. And you can leave it like that or simplify to 4 over 3. And again, it's important to understand the process, which is based on this identity and this kind of algebra that is ensured by multiplying and dividing by what we would like to be there so that everything balances out. And that's all. Thanks for watching.